define h as, we're going to use a chain rule again. But this time, f is inside of g, which means we take the derivative of g first, says the chain rule. Then we have to multiply this by the derivative of f. I don't know. I think most people will probably get this one right over number 5. I think it was number 5. So then I got to plug in 3, says that little 3 right there. So I get f of 3, which is 5. So I have g prime of 5 now. You always work from the inside out on these dudes. And then f prime of 3 is going to be 4. Whoops, not equals. So times 4. Let's rewrite. Let's write g prime of 5 is going to be negative 4. And we have to multiply this by 4. So that gives us negative 16. Bam. Boom shakalaka. Shikity dakity kuga. Number 9. Number 9. Number 9. Oh my goodness. We still have the same looking thing. But this time it says take double prime. Oh my goodness. Alright, let's write this out really quick. We have g prime of f. We already did this one from the previous one. It was the chain rule. Now I have a function multiplying to a function. And inside of this function, I have another function. Oh, snap. That means we're going to be using the chain rule inside the product rule. So let's take the derivative of this first guy. In order to take the derivative of this first guy, I'm going to have to do the product rule yet again. And so if I take the derivative of the outside function first for this one, I got to take the derivative of this whole thing. And then we got to do the chain rule to this guy. So I get the derivative of g prime is g double prime with the f inside. And then I have to multiply this, because I'm still on this, I have to multiply it by the derivative of the inside. Alright, I'm going to put brackets around this dude, because that was pretty gnarly. Now the product rule says you take the derivative of this one, and then you multiply it times a second. Okay, so I got to multiply this by f prime of x. Plus, okay, we took the derivative of this guy. That one's done. Now we got to take the derivative of that guy times the first. And so let's write the first. We have g prime with a capital F of x inside. We're going to multiply this dude times the derivative of f prime. The derivative of f prime is f double prime. All right, so now we got to plug 3's into all of those. Man, that's a lot of x's. I'm not going to write all the 3's. Let's just do it. All right, let's go to this one first. We have f of 3. F of 3 is going to be 5. So I'm going to plug 5 into g double prime. And I'm going to write it because, you guys are learning and stuff, even though I want to be lazy here. What's f prime of 3? F prime of 3. Let's see, that's going to be 4. All right, I'm going to put my brackets around that. I just want to make sure I multiply it to whatever that is. F prime of 3 is going to be 4. Hey, it's again. All right, so times 4, and then plus. And I have this g prime. We found this earlier, I think, but it's on my other screen. I can't get to it. So f of 3 is going to be 5. So we have g prime of 5. And we're going to multiply it times f double prime of 3. Ooh, something different. F double prime of 3 is negative 3. All right. Now we have g double prime of 5, which is 11. So I'm going to put 11 right here. You're going to multiply it times 4. Then you'll multiply that times 4. And then we have g prime of 3. No, I'm sorry, g prime of 5. So that's going to be negative 4. So negative 4. And I'm multiplying that times negative 3. Oh, man. We are, oh, dang it. Yes, okay. No, that's that and that's that. Okay, I thought we were forgetting f double prime. Okay, so this is going to be a 44. 44 times 4 is a big number. I don't know about you. I don't do that stuff in my head, especially on tests. 4 times 4 is 16, plus 1 is 17, 176. So I have 176 times 4. No, what was it? Okay, so I have 176 plus positive 12, because negative 4 times negative 3 is positive 12. That's going to be 188. And look at that. There's our answer. Sweet. Finally, our last table problem. Okay, we got... Oh, look at this. A natural log. Where'd you come from? I've been missing you when we have an f inside of it. So we're going to plug 3 in after we find the derivative of this guy. Let's see. The derivative of the outside function first, then the derivative of the inside. Man, chain rule is so popular right now. He's so hot right now. Okay, let's see. 1 over what's inside. That's the derivative of any natural log. It's 1 over whatever's inside. And then we have to multiply this by the derivative of what's inside, which is f prime. All right, so we plug in our 3's to this stuff. Oh, I guess we could have just written f prime of x over f of x. We plug 3's into this. Let's see, what is f prime of 3? That's going to be 4. And then we have f of 3, which is 5. And that's our answer, 405. Oh, of course they give me decimal. That's 0.8, right? Yeah, 0.8. There you have it. All right, since this video is short, let's do number 11. This one looks gnarly. This is definitely a level 3 right here. All right, so I see this inverse thing, and then I read this. It says if f and f inverse are both differentiable, and it gives us this information and this information, then which of the following must be the line tangent to the graph of the inverse of f. All right, so there's a lot of stuff going on here. So in order to find the function here, there's a couple different ways to do it. First, let's make the tables of our two functions because it helps us think. All right, we got the f of x. If we plug in 3, we get 5. Now the other function that is not here that we don't see, well, they don't give us any other information for, is the f inverse. If we have f inverse, that means the x and the y are flipped. And then we have a table for, and we don't really need this table, but I'm writing it anyways, f prime. So when we plug in 3, we get 7. All right, now maybe you might think that f of negative 1x prime would just be this switched. Wrong. Don't do that. Okay, you can't do that. But there is a formula to find f prime of the f inverse. But before we do that, let's talk about this tangent line, because I think there might be something in here that'll help us solve this problem. I don't know. I haven't solved this problem in a very long time. I don't remember how to do it. Line tangent to the graph of f of 1. Well, we know that 5,1 or 5,3 is a point on this graph, and so if we're talking about tangent lines, don't forget we have y minus for this one it's going to be, oh no, wait, yeah, with a plugged in, that's right, f inverse. Okay, then we have f inverse prime. That looks really weird. I've never seen it written like that. Then we have x minus a. All right, so this is just a slope. Okay, if you're from algebra, then that would be your m. This is just your y1. All right, and this is your x1. Now, since we're in calculus, I'm going to write it calculusy. All right, we know that the a can be 5, and the y can be 3. So if I plug it in, it would look like this. We got y minus 3 equals the slope. Now I'm going to go ahead and put m because it's easier to write. X minus 5. Now check it out. What you would do here is you would add 3 to both sides to make it look like what we got over there. So I got 3 plus m times x minus 5. All right, do we have that in here? Yeah, we have it right here. Okay, so this looks very similar to this, but my question is 7 the slope? Because if it's not, then maybe we did something wrong, and one of these other answers is our solution. But I'm pretty confident that this is our solution, but let's find out. Let's find the slope of this guy, of the inverse of f. And so we're finding the slope at 5. And so we're trying to find f inverse prime of 5. I've just never seen it written like that. I don't know. Okay, so we're going to go 1 over, and we have f prime with f inverse plugged in. Okay. We're used to seeing this with a g. Like, let's say if g was the inverse function, then g prime would equal 1 over f prime with g plugged inside. But our g is f inverse with the little -1 thing, which is kind of weird. So let's see. Do we have f inverse of 5? Yes, we do. It is 3. So if I plug in 3 right here, I plug in 3. We got f prime of 3, f prime of 3. Do we know what f prime? Oh my goodness. These tables are so helpful. All right, so I put a 7 in there, so we get 1 over 7. Oh, snap. Look at that. That was a trap right there. Oh, did you see that? You see that? That is not the answer. Oh my gosh. Oh my gosh. Those lazy students would have chosen that one. They wouldn't have checked to see if that one was correct. Oh, snap. This one also has a 3 and a 5. What a dork. So it could have been this one or this one. So I would have had to check the slope anyways. All right. So that's my slope, the 1/7. So I plug that into the m, and this would be my answer.